In this video, we'll be talking about arithmetic combinations of functions. Now, for two functions f and g, we can compute an arithmetic combination of f and g. Now, these come in four basic varieties, and we're going to define these four in the following way. First, we'll define the sum of f and g to be f plus the function f plus g, where f plus g of x is just the value of f of x plus the value of g of x. Similarly, we define the difference of f and g to be f, the function f minus g, which when we evaluate at x is really the value of f of x minus the value of g of x. Continuing on, the product of f and g we define as the function fg, f times g, which when we evaluate at x is really just the value of f of x times the value of g of x. Finally, the quotient of f and g we define as the function f over g, which really we say that function evaluated at the value x is really just the value of f of x divided by the value of g of x, which is assuming, of course, that g of x does not equal 0, since we cannot divide by 0. Also, the domain of any combination consists of all real numbers where both expressions are defined. Okay? Also, an important note here, because this messes with students, keep in mind that f and g are functions of x. So you're not saying here f times x plus g times x. You're saying f of x plus g of x. Again, this should not be thought of as the distributive property, because it's not. This also should not be. And here, you know this isn't the distributive property because the distributive property doesn't even work with three values like this. Okay? So please try to keep that in mind. Now, the big point in all of this is that we can combine any two functions we want using addition, subtraction, multiplication, division. For example, suppose we're given f of x plus equals 2x plus 1 and g of x equal x squared plus 2x minus 1. Then we could find the value of, the function, the sum, f plus g of x. And namely, we know that the sum, the function f plus g of x, is defined to be f of x plus g of x. Which, plugging in, we have 2x plus 1 plus x squared plus 2x minus 1, which that then gives us the plus 1, the minus 1 would cancel, the 2x and the 2x combine together, so we have 4x, so we have x squared plus 4x, and that would be it. Now, we sort of have two ways to evaluate at x equal 3. We sort of have the first method. Method 1 says that we can just plug in, we know that f plus g of 3 is just 3 plugged into that. So that would be 3 squared plus 4 times 3. And so in other words, that would be 9 plus 12. 9 plus 12 is 21. Now, on the other hand, our second method, what we could do is we could also say that this is f plus g of that. F plus g of 3 we know is f of 3 plus g of 3. So we could evaluate it that way, using this property. If you plug in 3 into f, you'll get 6. You'll get 6 plus 1 is 7. Plus, plug 3 into g, you get 9. Plus 6 is 15, minus 1 is 14. 7 plus 14 is still 21. So either one of these two methods works. So now, let's have you go ahead and try, given that f of x is x squared and g of x is 1 minus x, find f plus g of x and then evaluate the sum when x equals 2. On the count of 3, I'll reveal the answer. 1, 2, 3. So here we computed f plus g of x, the sum, and then we went ahead and did both of the two methods. So whichever method you want to use will work in this situation. And now let's go ahead and consider an example with subtraction. So given f of x equal 2x plus 1 and g of x equal x squared plus 2x minus 1, let's find the difference between f and g, and let's evaluate the difference when x equals 2. So here we know that f minus g of x is 2x plus 1 minus x squared plus 2x minus 1, because this is f of x, this is g of x. And so we have 2x plus 1. Here we need to remember to distribute minus x squared minus 2x plus 1, distribute the negative. And so we end up with the 2x's would cancel, 1 and 1 is 2, so we should have 2 minus x squared. Again, I could do this either of the two methods that I had before, but I'm going to go ahead and stick with method 1 for the rest of the time here. So using method 1, we have that x squared, so we'd have f minus g of 2, which is 2 minus 2 squared. 2 minus 4, so 2 minus 4, which is negative 2. Good. Now it's time for you to try an example, so go ahead and given f of x equals x squared and g of x equal 1 minus x, once again, try to find the difference and then evaluate the difference when x equals 3. On the count of 3, I'll reveal the solution. 1, 2, 3. And there you have the solution. Again, remember to distribute the negative, and here you just have to plug in 3 into the function. Moving on to multiplication. Let's look at the functions x squared and g equal x minus 3. Let's find the product of the two functions, and then let's evaluate the product when x equals 4. So if we have here, that we know that f times g of x is f of x times g of x, which is x squared times x minus 3, which is x cubed minus 3x squared through distributing. And so fg of 4 is just 4 plugged into there, so 4 cubed minus 3 times 4 squared. Again, order of operations, we do the exponents first. 4 to the third is 64. Minus 4 squared is 16. 3 times 16. 3 and 16 are 48, so we have 64 minus 48, which is, if you remember this was 4 times 16, you would know that this is 16. And now it's time for you to try an example, so go ahead and compute the product for our two functions we keep using, x squared and g of x equal 1 minus x. Then evaluate the product when x equals 3. On the count of 3, I'll reveal the solution. 1, 2, 3. So here you see the product compute out, and then we just plug in 3 into there. So note also, through all the examples we've done so far, that the domain of all of our examples have been all real numbers. The reason that we need to make that remark about the domain is that with division, the domain can get a little bit more interesting, namely because we know that we can't divide by 0. So, for example, let's find f divided by g of x and the quotient function g divided by f of x as well, for the function square root of x and g of x. Then we're going to also find their domains. So, for our solution, we have here that we have f over g of x is f of x over g of x by definition. And so what we actually have here is the square root of x over square root of 4 minus x squared. Or, if you prefer, you can also combine the square root to get square root of x over 4 minus x squared. It's kind of your choice in that sense. We'll look at the domain of both expressions in a second, but let's look at g over f of x. So for this quotient, it's g of x over f of x. which is square root of 4 minus x squared over square root of x. Or, if you prefer, you can simplify this down to 4 over square root of 4 over x minus x by combining the square roots. However, we need to worry a little bit about this. So here, for our domains, we need to think a little bit. So here, we know that each f and g, we need to worry about each of their domains. So, what is the domain of f? The domain of f is that x needs to be greater than or equal to 0. The domain of g is a little bit harder to see, but we need that 4 minus x squared is greater than or equal to 0, which would mean that we need x to be between negative 2 and 2. So, using both of these two domains, we have that the domain of the whole expression we know is those, plus we need the bottom to not be 0. Well, that would be that x cannot be negative 2 or 2. So the total domain here, plus we need x greater than or equal to 0. So combining all of these together here, we actually have that the domain is going to be x between, x has to be greater than or equal to 0. But it also needs to be strictly less than 2, for if it's equal to 2, the bottom equals 0. Or, if you prefer interval notation, 0 to 2. So either one of those. On the bottom, we can do the same thing. Again, we need the intersection of these, so we know at least that the domain needs to be between 0 and 2. And so, what else do we have? We also have that we cannot have x equal to 0 in the denominator. So, because of that, we actually have that x has to be greater than 0, because it can't equal it. But it could be still less than or equal to 2, because the top can be 0. That's not a problem. Or, again, if you prefer, 0 to 2. Closed at 2, open at 0. So now, let's go ahead and have you work an example. Find both the quotients f over g and g over f for the functions f of x equals square root of x minus 3 and g of x equal the square root of 16 minus x squared. Then find the domains of f over g and g over f. On the count of 3, I'll reveal the solution. 1, 2, 3. So here you see that we need, here the domain of f is x greater than or equal to 3. The domain for g is x has to be between negative 4 and 4. Otherwise, this expression becomes negative. And so, the expression on the inside, and then we have to take a square root of a negative. And so, when we calculate out, we also have the added condition that in this one, 16 minus x squared cannot be 0, which means x cannot be negative 4 or 4. And so, we end up with this, and then you do a similar thing with g over f as well. For more practice, be sure to see the textbook, section 1.8, and look at page 81 and work numbers 1, 3 through 24, 45, and 46. And in our next video, we'll talk about function composition.